So today we're going to do class G. We're talking about the double angle formulas and the half angle formulas. And let's see, hopefully you guys can all see all right. Let me make sure I'm recording right. Yes, I'm recording. Okay, good. Yeah, okay, so the double angle formulas for sine and for cosine. I will also mention there is one for tangent, but we're not going to look at it. Is obtained by just using the angle sum formula. So the angle sum formula for sine, which we talked about yesterday, is sine of a plus b is sine of a times cosine of b plus cosine of a times sine of b. And all we're going to do to find the double angle formula is replace both a and b with the same angle. So sine of theta plus theta is going to be sine of theta times cosine of theta plus cosine of theta times sine of theta. But here's the thing, sine of theta times cosine theta and cosine theta times sine theta are really the same. They're both sine of theta times cosine theta. So the right-hand side is really 2 times sine of theta times cosine of theta. And the left-hand side, theta plus theta is 2 theta. So we can write this as sine of 2 theta. So there's the double angle formula for sine of 2 theta. It's equal to 2 sine theta cosine theta. And this does come up on occasion, for sure, in various forms. Same idea for cosine of theta plus theta. We're going to use the angle sum formula. Cosine of a plus b is cosine of a times cosine of b minus sine of a times sine of b. We can replace a and b with the same angle theta. So cosine of theta plus theta should be cosine of theta times cosine of theta minus sine of theta times sine of theta. And we can replace, right, we can rewrite theta plus theta as 2 theta. So this is cosine of 2 theta. And cosine of theta times cosine of theta is cosine squared of theta. And sine of theta times sine of theta is sine squared of theta. I will point out, this is not the trig identity that's equal to 1. So I just want to make sure everyone's super clear with the fact that this is not equal to 1. Right? That's cosine squared theta plus sine squared theta that's equal to 1. Cosine squared theta minus sine squared theta is equal to cosine of 2 theta. And something else I want to say, a couple things. Thing one, if someone ever asked you to do tangent of 2 theta, I couldn't tell it. I could almost guess what the formula is. I don't really know. But if someone said, James, what's tangent of 2 theta? I would just say, oh, it's sine of 2 theta over cosine of 2 theta. And then I would use the formulas for each of those. That's going to be 2 sine theta cosine theta divided by cosine squared theta minus sine squared theta. That's how a rational person would actually do something like that, I think. You can also memorize this formula. I am not going to talk about it in this class. I'm never going to ask you what tangent of 2 theta is. It's not really particularly important. Okay. The other thing I want to point out is, I noticed on your last homework, a few of you were not writing things like cosine squared and sine squared exactly right. So I wrote a little discussion, or not discussion, an announcement in Canvas about the right ways and the not right ways to write a trig function to a power. So you should all look at that just to make sure you're writing it the right way. I didn't knock you for writing it the wrong way, but I just want you to know, right, you want to write it the right way so that people know what you're writing. So this is the preferred way of writing a trig function squared, which you could also write as like cosine of theta quantity squared. But what you can't do is write it like this. Because then if you write it like that, someone's going to think you mean you're squaring the angle and then taking cosine of that angle squared, which is a totally different thing than cosine of the angle quantity squared. So just be careful. Notation can be a little bit wonky. Okay. So I know I've written some things ahead of time. That's kind of it. So with the angle sum formulas, as I hope some of you have seen already with the homework you've been working on, or from class yesterday, right? Class yesterday, we definitely talked about finding like cosine of 75 degrees or sine of 7 pi over 12, things like that, where you actually use the formula to find sine and cosine of some new angles. We're not going to do that with the double angle formula because it doesn't really allow us to. Right? Any angle that's twice an angle we already know how to find is an angle we already know how to find the cosine of. So for example, you could use the double angle formula to find cosine of 120 degrees. It'd be cosine of 2 times 60 degrees. And then applying the formula, cosine of 2 times theta is cosine squared of theta minus sine squared of theta. So in this case, theta is 60 degrees. And then cosine of 60 degrees is 1/2. So that's 1/2 squared. And sine of 60 degrees is the square root of 3 over 2. So that's the square root of 3 over 2 squared. And that's going to be 1/4 minus 3/4, which is negative 2/4, which reduces to negative 1/2. And no one should ever find cosine of 120 degrees this way unless you really, really, really want to for some weird reason. The way we should find cosine of 120 degrees is to say, oh yeah, the reference angle is 60 degrees. 180 minus 120 is 60. The angle's in quadrant 2. Quadrant 2 where we know that sine is positive and cosine is negative. So I would find cosine of 120 degrees by saying it's going to be negative cosine of the reference angle. And cosine of 60 degrees, we already said was 1/2. That's the way, at least I would encourage you to find something like cosine of 120, right? You never really want to use the double angle formula to evaluate any angles. You never should have to. There's always going to be a different way. So what do we do with the double angle formula? Well, to be honest, it mostly shows up like in Calc 2 when you're trying to evaluate some intervals sometimes. And sometimes you have something that looks like sine of 2 theta and you want to rewrite it as 2 sine theta cosine theta. That's kind of a lot of the time when you're using double angle formulas. I will also mention that the double angle formula for cosine shows up in some other formulas. There are some other questions we can ask though. And again, these are going to be the same kind of variety of questions I've already been asking you, where I'm going to give you like sine and cosine of an angle and ask you to find something else, like the following. Suppose we are given that cosine of theta is equal to, I feel like this light back here is not great. Let me turn that off. Sorry. Jack, that's a little better. Cosine of theta is equal to the square root of 7 over 4. And we are also given that theta is in quadrant 4, where cosine is positive and every other sine and tangent are negative. And then we're being asked to find sine of 2 theta and cosine of 2 theta. What I want to really, really emphasize here is we cannot just say cosine of 2 theta is twice that. It is really, really not true. And cosine of 2 theta does not equal 2 times cosine of theta, which would be the square root of 7 over 2. Can't be. Instead, we have to use the formulas. Cosine of 2 theta is cosine squared theta minus sine squared theta. So we've got part of it, right? I know that cosine squared is going to be, well, cosine is the square root of 7 over 4. But then I have to find sine. So I will mention, this is not the way I usually do it, but one way you could do this if you wanted to would be just say, oh, but sine squared is 1 minus cosine squared. And then we already know what cosine is. So you could totally do that. That's never the way I do these problems because it's, I don't know why I don't do it that way. But we already have to find sine for this one because sine of 2 theta is going to be 2 sine theta times cosine theta. So since we have to find sine here, we might as well put it there as well. And to find sine, we're of course going to draw a triangle. where the adjacent side is the square root of 7 and the hypotenuse is 4. And we're going to find the unknown side. So we have the square root of 7 squared plus x squared equals 4 squared, and then 7 plus x squared equals 16. X squared equals 16 minus 7, which is 9. So x is going to be the square root of 9, which is 3. Great. Now we can find everything we need. Sine of theta is going to be 3/4. Or is it? Am I forgetting something?
Is there a -3?
Exactly, because we're in quadrant 4. And cosine theta is the square root of 7 over 4. If you multiply this out, I would probably cancel a 2 there and a 2 there. So I'm going to have a 3 times root 7 on top and a 2 times 4 on the bottom. So there's sine of 2 theta, -3 root 7 over 8. And then we can figure out what cosine of 2 theta is going to be as well. Cosine of 2 theta is going to be cosine squared, which is root 7 over 4 squared. And then sine squared, and sine we just figured out was, where'd you get? Oh, sine is -3 over 4. Squared. So I end up with 7 over 16 minus a negative thing squared is positive, so it's going to be minus 9 over 16, which is going to equal -2 over 16, which reduces to 1 over 8, -1 over 8. So let me ask you guys, looking at this, we can see that sine of 2 theta is negative and cosine of 2 theta is also negative. Can you tell me in the chat what quadrant, 1, 2, 3, or 4, our angle 2 theta has to be in? Guys are like, no, I don't want to. And yeah, you can also chat directly to me if you don't want to chat to everyone. But yes, I'm seeing definitely correct answers. Those are both right. Everyone who has messaged me so far is correct. Yep. For sure. Everybody, yep. So let me say, we are going to be, so 2 theta, I should say. So I might have not been super clear. Our angle theta is definitely in quadrant 4, but 2 theta has to be in quadrant 3, because quadrant 3 is the quadrant where both sine and cosine are negative. And that's what we have. Sine of 2 theta was a negative number, and cosine of 2 theta was also a negative number. So if anyone ever asks you what quadrant an angle is in, usually the expectation is for you to say, oh, I know sine is either positive or negative, cosine is either positive or negative, and then make your decision based on what positive or negativeness sine and cosine both have. That is usually what people expect. Yeah, all right. Let's look at one more example of this variety, and then we'll move on. So I forgot to put my fan in here, and it's kind of hot today. Oh well, I'll survive. So let's look at one more example. Let's say we have that sine of theta is equal to positive 1/6, and theta is in quadrant 2. We're going to ask all the same questions. And this time I'm going to do the cosine one a slightly different way, even though we don't have to. So I want to find sine of 2 theta, cosine of 2 theta, and what quadrant 2 theta is in. I should mention, you can narrow down what quadrant 2 theta is in, but you can't know for sure without doing more work. If theta is in quadrant 2, that means we know that theta is between 90 degrees, and 180 degrees. And if we multiply everything by 2, we know that 2 theta is between 180 degrees and 360 degrees. But that means it could be in quadrant 3 or it could be in quadrant 4. And we don't have enough information without figuring out whether these are positive or negative to figure it out. Well, since we know we're in quadrant 3 or 4, we know that sine is going to be negative. Let's figure out what cosine is going to be. Or let's figure out what the triangle is what I should really say. So sine of theta is 1/6, and sine is the opposite of hypotenuse. This third side, I'm going to find, let's see, x squared plus 1 squared is 6 squared. X squared is going to be 36 minus 1. So x is going to be the square root of 35. So if I want to find sine of 2 theta, that's going to be 2 sine theta times cosine theta, which is going to be 2 times 1/6 times, it's going to be positive or negative here. Well, what quadrant are we in? Oh, we're in quadrant 2. So cosine has to be negative square root of 35 over 6. And then we can simplify this a little bit. A 2 cancels here. So we have 1/3 times negative square root of 35 over 6. That's going to be negative square root of 35 over 3 times 6 is 18. And that confirms, oh yeah, sine is negative. I should say sine of 2 theta is negative, meaning 2 theta has to be in either quadrant 3 or quadrant 4. So now let's find cosine, but I'm going to find cosine a slightly different way because we're going this direction anyway. So cosine 2 theta is cosine squared theta minus sine squared theta. But what I want to point out here is we could have done this problem, this part of the problem, without ever having drawn this triangle by using another trig identity, the fact that cosine squared theta plus sine squared theta equals 1. Or more importantly, maybe not more importantly, but for this problem, cosine squared theta equals 1 minus sine squared theta. So I can replace the cosine squared with 1 minus sine squared. So then I have 1 minus sine squared theta minus sine squared theta, which is really just 1 minus 2 sine squared theta. And then I can figure it out. I know that sine of theta is equal to 1/6. So sine squared theta is 1/6 squared. That's going to be 1 minus 2 times 1/6 squared. That's going to be 1 minus 2 times 1/36. That's going to be 1 minus, I can cancel a 2 here and a 2 here. 1 minus 1/18. And 1 minus 1/18, or 18/18 minus 1/18 is 17/18. You would have gotten the same thing if you'd done it this way and used this, right? Cosine squared would have been the square root of 35 over 6 squared, or the negative square root of 35 over 6 squared, which would have been 35 over 36. And sine squared would have been 1 over 6 squared, which would have been 1 over 36. And then 35/36 minus 1/36 is 34/36, which reduces to 17/18. Either way would work, but sometimes you can cut out some of the work. So sine being negative, I should say, sine of 2 theta being negative and cosine of 2 theta being positive means we're in which quadrant? Quadrant 3 or quadrant 4? I can't tell if I'm getting new answers or not because all the previous answers also say quadrant 3 and quadrant 4. So I'm gonna, I can look at the time though. So it is in quadrant 4, right? Where sine is negative, but cosine is positive. So this is kind of most of the only type of question we really ask involving the double angle formula currently. And it's going to pop back up again when you take calculus. One thing I like about this setup is, as you saw yesterday on Monday, I can erase the other side of the board while you still can look at that side of the board, which is kind of great. What time is it? Okay, good. Time's good. Wait, can you go to the last? Yes, of course. So for the cosine part, there's two different ways. Well, there's actually three different ways of doing it, really. But so the way I did it, the first way I did it was this path. I replaced cosine squared theta with 1 minus sine squared theta, right? Because of the trig identity, that cosine squared theta is equal to 1 minus sine squared theta. And then I rewrote 1 minus sine squared as 1 minus 2 times sine squared of theta. And then I said, oh, I know that sine of theta, it was given to me that sine of theta was equal to 1/6. So 1 minus 2 times sine squared became 1 minus 2 times sine theta, which is 1/6 quantity squared. And then I simplified. 1/6 squared is 1/36. 2 times 1/36, I can cancel a 2 on top and 2 on the bottom and get 1/18. So I have 1 minus 1/18, which becomes 18/18 minus 1/18, which is 17/18. Alternatively, you could also just use the original formula as is and say cosine squared is going to be, well, cosine is, I'm just going to point out, that's cosine theta right there. Cosine theta squared is going to be 35/36. And sine squared theta is going to be 1/6 squared, which is 1/36. And if you subtract these, you get 34/36, which reduces to 17/18. Hopefully that clarifies what's going on. Okay. You're welcome, of course. So one thing to be aware of is that there are two alternate double angle formulas for cosine of 2 theta, which we kind of already talked about, one of them. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And as we just saw, you can replace cosine squared theta with 1 minus sine squared theta. And then you can rewrite this as cosine of 2 theta equals 1 minus 2 sine squared theta. There's another alternate formula as well. We should need chairs in this room. So instead of replacing cosine squared with 1 minus sine squared, you can replace sine squared with 1 minus cosine squared. So this other version is going to be cosine of 2 theta equals cosine squared theta minus sine squared theta, but instead of sine squared theta, we're going to write 1 minus cosine squared theta. We're going to distribute the minus sign. So cosine of 2 theta equals cosine squared theta minus 1 plus cosine squared theta. And then we're going to say that cosine of 2 theta equals cosine squared theta plus cosine squared theta is 2 cosine squared theta minus 1. Something to be careful about, because I've seen it happen a lot of times, is it's really easy when you're writing line after line after line of this for cosine squared theta to accidentally become cosine 2 theta. Right, so just be careful, right? If something's a power, you need to make sure it stays up in the exponent where, yeah. I've seen lots of powers travel down to no longer be powers, so just be careful. That's like the name of the game. Just be careful with the math. If you can be careful, you usually do pretty all right. But a lot of math, unfortunately, is bookkeeping and making sure that you're keeping track of things correctly. So the reason we really kind of care about these formulas is because they let us find the half-angle formulas. Let me do one thing here real quick. take a screenshot of everybody here. Not of your pictures, just of your names. Don't worry. Okay. All right. So yeah, we like these because they help us find the half-angle formula. So what we're going to do for each of these here is we're actually going to solve this one for sine. And we're going to solve, sorry, I should say, we're going to solve this one for sine of theta. And we're going to solve this one for cosine of theta. I feel like we might need a little bit more room. So let's go to the other side. No, I failed. Let me erase over here. Best practice. So the half-angle formulas are kind of interesting. They definitely do come up in various places. So let's talk about them. So half-angle formulas, there's one for cosine and there's one for sine. And they both come from those identities we just talked about. So let's talk about the cosine one first. So we're going to start with this formula here. I'm going to write it slightly opposite of how it is. I'm going to write this side on the left and this side on the right. So I'm going to have 2 cosine squared theta minus 1 equal to cosine of 2 theta. So all we're going to do is solve for cosine of theta. So I'm first going to add 1 to both sides. So 2 cosine squared theta is equal to 1 plus cosine of 2 theta. And then we're going to divide both sides by 2. Cosine squared theta equals 1 plus cosine of 2 theta divided by 2. And honestly, this formula is a formula that does come up a lot. It's not what our books typically refer to as the half-angle formula, but it is a useful formula. So I'm just going to box this here because this is useful. But then the half-angle formula that we actually want is we have to take the square root. So we're going to get cosine of theta equal to plus or minus the square root of 1 plus cosine of 2 theta all divided by 2. And that is the half-angle formula. Some people, not me, but some people prefer to write this a different way. So I'll show you that just because I feel like I should. Some people like to write it the following way. They like to write cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine of x all over 2. To me, this is less nice because usually we're trying to find like cosine of an angle, and I don't want to have to think about, okay, what is my angle actually half of? But if you, for some reason, have seen it this way and really like it, perfectly fine. There's also one for sine. So I'm going to start with this formula. Cosine of 2 theta equals 1 minus 2 sine squared of theta. And I'm going to try and solve for sine. So I'm going to add 2 sine squared over here. Sorry, 2 sine squared of theta. I'm going to subtract cosine of 2 theta from both sides. 1 minus cosine of 2 theta. And then I'm going to divide both sides by 2. So sine squared of theta equals 1 minus cosine of 2 theta divided by 2. And then I'm going to square root both sides. Oh, and I'm going to point out, right, this is a useful formula as well. This comes up quite often. And then if we square root both sides, we get sine of theta equal to plus or minus the square root of 1 minus cosine of 2 theta all over 2. Or the alternate version, which is not my favorite, sine of x over 2 equals plus or minus the square root of 1 minus cosine of x all over 2. The green ones are definitely the versions I refer back to. I will point out two things. Thing one, the formulas are very similar, right? They're virtually the same, except for it's a plus for cosine and it's a minus for sine. The other thing I'll point out, and this is a little bit, we'll talk about this as we do some examples here, is that there's a plus or minus here. It doesn't mean that cosine is real of like, for example, if I was going to find, say, cosine of 22.5 degrees, which is a typical example, we'll see in a minute here. It's not positive and negative, right? We have to decide if it is positive or negative based on the quadrant that our original angle is in. So since 22.5 degrees is in quadrant 1, both cosine of 22.5 degrees and sine of 22.5 degrees would be positive, whatever this whole mess in here is. So that's kind of the gist of things. Let's see if there's anything else I want to say about this before we do some examples. No, yeah, okay. Yeah. Just for the sake of observation, I will point out if you add, so let me add, so without looking at the board, what's cosine squared plus sine squared equal to? I know you all know.
What?
Thank you. Yes, appreciate it. Well, look, if you add cosine squared plus sine squared, you get 1 plus cosine 2 theta over 2 plus 1 minus cosine 2 theta over 2. If you add those together, you get 1/2 plus 1/2, which is 1, and the positive cosine 2 theta over 2 and the negative cosine 2 theta over 2 cancel out. So these totally do add up to 1, which is kind of neat. Just wanted to say that. All right, so let's do some examples. So there's really only one type of angle where you really use the half angle formula. There are two where you kind of can, but one of them is kind of awful and not necessary. So yeah, let's do this. So let's find sine of 22.5 degrees. So as you might have noticed, I'm picking an angle that's half of an angle that we know how to deal with. Right? Sine of 22.5 degrees is sine of half of 45 degrees. So here's the thing. I don't want to think about this, right? I don't want to have to be like, okay, 22.5 degrees is x over 2. So x is 45 degrees. That seems more work than I want to do. I'm just going to do this and say, okay, sine of 22.5 degrees is plus or minus the square root of 1 minus cosine of 2 times 22.5 degrees. And then 2 times 22.5 degrees is an angle. We know it's 45 degrees. So that's kind of why I like writing it this way better. It seems to make more sense. So it's going to be plus or minus the square root of 1 minus cosine of 2 times 22.5 degrees, all divided by 2. Now, the lame part about this is that there's a lot of simplifying that we should do. Like the problem itself, if you memorize the formula or if you know the formula, if you see the formula, the actual figuring out of it is not that hard. There's just two things we have to do. First of all, is it positive or negative? Well, this angle is in quadrant 1, so it's got to be positive because sine is positive in quadrant 1. And then the other thing you have to do is you actually have to deal with this. So that's cosine of 45 degrees. This is going to be positive square root of 1 minus cosine of 45 degrees over 2. And then we know that cosine of 45 degrees is the square root of 2 over 2. This is equal to positive the square root of 1 minus the square root of 2 over 2 all over 2. And this answer is not wrong. And it's probably fine if you leave your answer like this. But if you tried to look up, like, if this problem was a question in your homework, you tried to look at the answer in the back of the book, this is definitely not the answer you would see in the back of the book. There's like 2 or 3 simplification steps that we need to do so we can see what this is more typically written as. So the first thing we're going to do is in the inside of the square root, I'm going to write it fully out. So we're going to write this as 1 minus the square root of 2 over 2 over 2, and we're going to multiply this by 2 over 2. So that we can get rid of that 2 in the denominator, or sorry, the 2 in the denominator of that fraction there. So if we distribute the 2, we get the square root of 2 times 1, which is 2. 2 times the square root of 2 over 2 is the square root of 2. And 2 times 2 is 4. And then there's one last step. What's the square root of 4? It's 2. So we can rewrite this as the square root of 2 minus root 2 all over the square root of 4. But that's the square root of 2 minus root 2 all over a 2 that is not inside the square root. I know it's kind of annoying to have to do all this, right? It's kind of, right, we're here and it's like 1, 2, right? It's kind of a bit of work, but the nice thing is for all these angles that are half of like an angle with a 45-degree reference angle, they're all going to look like this. The only thing that's going to be different is maybe it's a negative there, maybe it's a positive there, but they're all going to look like something square root of 2, either plus or minus the square root of 2, all over 2 in the denominator. How did the 4 become the square root of 4? So here's the thing. Yeah, good question. So right here, this is all in the square root. Right, so this is the square root of all of that. 2 minus root 2 all over 4, which is the same as the square root of the top divided by the square root of the bottom. There's a rule, right? If you have like the square root of a fraction, square root of a divided by b, it is equal to the square root of a divided by the square root of b. And so that's what we're doing here. We're just saying that is the same as that. And the reason we're doing it is because we know that 4 is a perfect square and the square root of 4 is 2. So if this seems a little terrible to you, I don't necessarily disagree. It's kind of a little terrible. Let's do a couple more examples and then let me actually look and see what else we have. Nope, I think that's it. All we have is more examples of this. So we'll do a few more examples of this and then we'll call it a day. Okay, so the thing I want to say is all of these examples are going to be half of an angle whose reference angle is 45 degrees, or half of an angle whose reference angle is pi over 4. So here are some common examples. You could have 22.5 degrees. You could have 67.5 degrees. You could have 112.5 degrees. You could have 156.5 degrees. I think that's right. 157.5 degrees. Sorry. If your angle has half a degree in it, it's a pretty good bet you're going to be using the HalfAngle formula. Or in radians, pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. Or anything pi over 8, it doesn't reduce. So these are the types of angles we pretty much use the HalfAngle formula for. I will point out one other example, but then maybe we'll do it, but I'll tell you how it's terrible. You could use the HalfAngle formula if you wanted to find cosine of 15 degrees. Because 15 degrees is half of 30 degrees. So you could say, oh, James, that's plus or minus the square root of 1 plus cosine of 2 times 15 degrees, which is 30 degrees, over 2. And then cosine of 30 degrees is the square root of 3 over 2. Yes to the question about the homework problem. I just don't know what that is. If you want, I can look it up. So it's going to be the square root of 1 plus the square root of 3 over 2 over 2. And then you can do the same sort of simplification. But here's the thing. I don't want to do that because I don't want you to do this that way. If you see something like 15 degrees, I think it's definitely more in your interest to do this as an angle difference. So although you're welcome to evaluate a trig function in whatever way you can figure out how to, I would genuinely encourage you to, if you're trying to do a trig function of 15 degrees, do it as a difference of two angles, not as a half angle formula. It's just going to be nicer, I think. Let me see if I can grab that problem before I get to things here. Sure, assignments. Looking at FG, problem 3A. Let me see. I probably have one like it, but I'm not positive. Ooh, 3. So I would say, Estefania, oh, sorry. I didn't mean to call you out. I apologize, but your question is good. So we definitely did a couple questions like that at the beginning of class where we have, right, so yes, we can do that. How about here's what I'll say. If you can hang out after class, I'm happy to do that, or we have office hours at 3:30, but I would like to do just a couple more examples of this so that people can see a few more of it. But yes, I think your question's good. And if you can't hang out, what I would say is I'll definitely get the class posted as quickly as possible. And the first few examples we did of double angle formula stuff are very similar to problem 3A from the homework. Yeah. But yes, I will try to get to that. But let's look at something like cosine of, I want to do, yeah, let's do cosine of 5 pi over 8. And really all we're doing here is we're just throwing the formula at it. Right? There's not much thinking going on here. So I know that cosine of 5 pi over 8, I'm going to use the half angle formula. It's going to be plus or minus the square root. Let's see, for cosine, it's the 1 plus cosine of 2 theta formula all over 2. For sine, it's the 1 minus. So you could say sine goes with subtraction for the half angle formulas, and I don't have a good thing for cosine. Sorry. Okay, let me ask you guys. Is it positive or negative? Well, actually, let me ask you a different question. 5 pi over 8. Is that angle in quadrant 1 or quadrant 2?
2.
Definitely. Right, it's a little bigger than half of pi. So our angle is in quadrant 2, and cosine is negative. Excellent question. What is 5 pi over 8 the half of? So here's the thing. I don't ever, that's a good question, but it's a question I never want to think about. And I actually didn't write this formula exactly right. I should have written cosine of 2 times 5 pi over 8. So I'm going to answer your question by asking a question. What is 2 times 5 pi over 8? Well, 2 times 5 pi over 8, I can cancel a 2 and get 5 pi over 4. Exactly. So the angle that the thing you're taking, the angle, let me read it again. 5 pi over 8 is half of exactly 2 times 5 pi over 8. So that's why I don't like, I know I erased it already. That's why I don't like the version where it's like cosine of x over 2 equals plus or minus square root of 1 plus cosine of x over 2. Because then you have to like ask yourself, what is my angle half of? Where it's easier just to be like, oh, I'm just taking this angle and I'm doubling it. That's the much more straightforward way to think about it. So then, the nice thing here is that these are all going to be like pi over 4s. And we know that cosine and sine of pi over 4 is either positive or negative square root of 2 over 2. This is going to be negative. And again, we have to be careful, right? This sign out here depends on what quadrant this angle is in. That angle is in quadrant 2. This sign here depends on what quadrant this angle is in. And 5 pi over 4 is in quadrant 3, where cosine is also negative. This is going to be negative square root of 1 plus, really, I was 1 plus negative root 2 over 2 all over 2. And if we could stop there, it'd be great, but we really should do the rest of the simplification steps. So then we're going to say that's negative square root of 1 minus root 2 over 2, and we're multiplying this by 2 over 2. On top, the 2 distributes, and we get 2 minus the square root of 2. On the bottom, 2 times 2 is 4. And then finally, the square root of the 4 on the bottom is just 2, but then it's no longer in the square root. So we can rewrite this as negative square root of just the top, 2 minus the square root of 2, all over the square root of 4, which is 2. And notice this answer has very, very much the same form as the answer that's not on the board that I was trying to go back to, that I already started. I do want to do, so I will say, they all kind of fall out this way, right? There's really not a lot else to the half angle formula. At least there's not a lot else to evaluating cosine and sine of angles using the half angle formula. It's very it's the same old thing, because there's not a lot of angles that are good candidates in the first place. It's really kind of things that are just like half of a 45-degree angle or half of an angle. There's reference angles, a 45-degree angle. So I will tell you, here's what I would encourage you to do. If this still seems a little dicey to you, how you go from 5 pi over 4, sure. So, right, I didn't go from 5 pi over 4 to negative root 2 over 2. I went from cosine of 5 pi over 4 is equal to negative root 2 over 2. Right, we're using the trig function. We're using the triangle, pi over 4, 1, 1, root 2. Cosine of pi over 4 is 1 over root 2, which rationalizes to root 2 over 2. And then cosine of 5 pi over 4 is going to be negative root 2 over 2. So yes, do be careful. I've noticed a few people have they kind of almost don't see the trig function, and it's like, oh, there's a 5 pi over 4 there. Right, but you're really taking cosine of 5 pi over 4, or cosine, right? You could also say, if you wanted to, that's cosine of 225 degrees. But whether you write it cosine of 225 degrees, which is the same as cosine of 5 pi over 4, either way you write it, it still is going to eventually end up being negative root 2 over 2. So I know it's 220. I want to say 2 quick things. I will tell you all that cosine of 9 pi over 8, if you want to practice one just on your own, here's what it should end up being. Well, first of all, 9 pi over 8 is slightly bigger than pi. That's in quadrant 3. So the overall answer is going to be negative. And then I know it's going to have exactly this form. 2 either plus or minus root 2 all over 2. And if it's plus or minus, well, usually the cosine formula would have a plus, but then 2 times 9 pi over 8 is 9 pi over 4, which is 8 pi over 4 plus pi over 4, which is 1 full revolution plus another pi over 4. So we're in quadrant 1. And since the cosine formula usually has a plus here, it's going to stay a plus. So I'll tell you the following 2 things. I'll tell you that, and I'll tell you this. Sine of 9 pi over 8, on the other hand, is going to be negative square root of 2 minus So those would be two good ones just to practice on, where you actually go through the process, right? So you go through the whole, it's going to be positive or negative, 1 plus for cosine, 1 minus for sine, cosine of twice the angle over 2, and then practice simplifying it. Because it's not, I mean, it's not like super hard, but it is kind of a pain in the butt. All right, the other thing I should do is I should answer the question somebody asked me. Can we go over something like homework problem 3A? Sure. So for 3A, here's the setup. You all, by the way, I should say, you all are welcome to go. It's 2:22. I'm not keeping you here. But if you want to see problem 3A from the homework, I'm going to talk about it right now. So you don't have to stay, but you are certainly welcome to. So for 3A, we're given the following. We're given that cosine of theta is equal to -4/5. And we are being asked, and we're also told that sine of theta is positive. And for 3A, we're being asked to find sine of 2 theta. And the whole gist for any of these types of problems, we're being asked to find sine of 2 theta or cosine of 2 theta, is we're expected to use the double angle identity or double angle formula. Sine of 2 theta is equal to 2 times sine of theta times cosine of theta. We already know cosine theta, it's -4/5. We have to find sine theta the way we usually find the other trig function. We know one of them by drawing a triangle. So cosine of theta is adjacent over hypotenuse. So the adjacent side is going to be 4, the hypotenuse side is going to be 5. You can call it -4 if you want. It doesn't really matter because you're going to square it, and either way, it's going to be 16. And then we want to find the third side here. So 4 squared plus x squared equals 5 squared. Or if you want, that could be a -4 squared, and it's still going to be 16. So I didn't give myself enough room here. 16 plus x squared equals 25. X squared is 25 minus 16, which is 9. So x equals 3. So then sine of 2 theta is going to be 2 times sine of theta, which is 3/5, and we know it's positive because they already told us sine was positive. And we don't even have to think about the quadrant here, although it is in quadrant 2 because sine is positive and cosine is negative. And cosine of theta is -4/5. So if we multiply this all out, 3/5 times -4/5 is -12/25. And if we multiply that by 2/1, it's going to be -24/25. So that's how you do a problem like 3A. And the same kind of idea for 3B is you'll use the cosine formula, right? The cosine formula is cosine squared theta. Sorry, not cosine squared theta. Cosine 2 theta, cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So then you can say, oh, well, cosine of theta is -4/5. So that's -4/5 squared. And sine of theta is +3/5. So that's going to be 3/5 squared. And then you can calculate this as 16/25 minus 9/25, which is 7/25. And now, since you guys are here, let me ask you anyway. We know 2 theta. We know sine of 2 theta is negative. We know cosine of 2 theta is positive. What quadrant does 2 theta have to absolutely live in? No doubt about it. Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Right, exactly. It's got to be quadrant 4 because quadrant 4, right? It can't be quadrant 1 because one of them is negative. It can't be quadrant 2 because sine is negative and sine is positive. It can't be quadrant 3 because quadrant 3 tangent is positive and cosine and sine are both negative. But cosine we know, or sorry, And cosine of 2 theta we know is positive. So it's got to be quadrant 4, where cosine is positive and sine is negative. So to answer the third part of this question, 2 theta is in quadrant 4, whereas the original angle theta is in quadrant 2. But I want to remind you all, you can't just double the quadrant, right? You really need to just be like, okay, I'm just going to look and see, is sine of 2 theta positive or negative? Is cosine of 2 theta positive or negative? And then I can determine what quadrant the angle is in. All right, that is all I have to say. Double angle formula, half angle formula. And then I think that pretty much concludes talking about the identities. Not that there aren't other identities out there, but those are all the identities that we are going to cover. We're going to start tomorrow talking about graphing the trigonometric functions, which is